Building functions out of functions, all right? So if we're given two functions are really just two equations. We can add two equations before. We've subtracted, we've multiplied and divided, and this is just the notation for that. If I want to add two functions, f of x and g of x, that's the notation telling you, hey, add the two functions. All right? It's f plus g of x. All right? And just like we can add, we can also subtract. And the notation for that would be f minus g of x. And notice the way I'm saying it, it's f plus g of x. The way it's stated is they put the word of in between. F plus g of x. Okay, f minus g of x. Just like we can add and subtract, we can multiply. F times g of x. And our last basic math operation is what? Division. F divided by g of x. Now we need to be careful to make sure that g of x is not 0. How come? Because we can't have 0 on the bottom of a fraction. Sweet. So now we actually have two functions here. We have f of x, which is x plus 1, and we have g of x, which is x squared minus 1.
Which is x plus 1 plus x.
That's it. If we're adding these two, we just add f of x plus x squared minus 1, which is g of x. So I'm just going to write this down in that order and combine them, right? Because if they're adding, all that is combining like terms. Now this is f of x, and I'm adding my g of x. Okay? So when I add that, what do I get? Well, I have 1x squared, right? There's only one x squared term. There's 1x, I'm going to add x. And that's it. How come?
Because the positive one cancel.
Yes, the positive one and negative one cancel. So this is actually f plus g of x. There you go. Not bad. This is stuff we've done in 8th grade, maybe even 7th. Now, subtracting, same thing. But order matters when you subtract. In addition, order does not matter. Addition and multiplication are the same. Order does not matter. Subtraction and division, order does matter. So if they put the f first here, that's the first function that you need to list. So it's x plus 1 minus my g of x, which is x squared minus 1. What do I do at this point? I do subtract. Well, what's the one thing we do when we subtract? And what's the one thing, what's the step called when we subtract? What do? People do it one of two ways. They either distribute the negative sign or keep change, right? I'll distribute the negative sign. That will give me a negative x squared, because it was positive, right? Negative times a negative is being positive 1, and that takes its place. Now I can combine that. Negative x squared, right? Yeah. Plus x, and now we have a plus 1, and the plus 1, now it's different, it's plus 2, and that's f minus g of x. Two operations left, multiplication and division. I'll do my multiplication out this way. That's f times g of x. Order does not matter. We have x plus 1, that is my f of x, times g of x, which is x squared minus 1. I just spoil this. Alright? Well, what is x times x squared? X cubed. What is x to the negative 1? Negative 1x, right? 1 times x squared? That's just x squared. And the positive 1 times the negative 1? Yes. You know, it's funny, a lot of people don't just shout out that answer. You know, everybody knows in their brain, they just don't want to sound wrong. Someone's like, yeah, I was going to say 0. Because people add instead of multiply. That's a common mistake when you go quickly. So that's the answer. And all I'm going to do is I'm going to write that in standard form, meaning the biggest exponent first, then the next biggest exponent I'm going to write next. And the term with the next biggest exponent comes after that. So, x cubed plus x squared minus x minus 1. And that's f times g of x. There you go. Not too crazy. Not too crazy at all. Not yet. Now let's tackle division. Order matters. So if they want the function with the f of x on top, you better make sure you write that. That is x plus 1. That's my f of x. That is going to be over my x squared minus 1. So, I mean, sometimes when you do things like this, that's it. You can't do anything. Am I done here? Can I do anything, or do you think that's it? Or that's it? I can't take out an x, but there is something else I can do, and I like that some of you guys are thinking, because when I throw that question out there, you know chances are that. No, yeah. What happens when we have terms in the top and bottom and one's factor across out like a nut? I can factor something, can I? What can I factor? The x squared minus 1. What does this factor out to? They're both perfect squares, right? X plus 1, x minus 1. Now, what can be canceled? The x plus 1 cancels the x plus 1. What's left in the numerator on top?
1.
A 1, right? So I've got 1 over x minus 1. And that's f divided by g of x. Right there. Not too bad. It's just the 4 basic math operations between two functions. Building functions out of functions. This is called a composition of functions. And notice that circle is not filled in. It is not multiplied. It's like a hollow circle. Okay? And that just means the way we say that is f of g of x. Okay? So we say f of g of x. And before we start to actually use it, let me explain what it does with some easy background knowledge that we should already have. Okay? If I have a separate function here, let's call it m. M of x equals x plus 3. And I wanted to ask you, well, what is m of 5 then? I insert a 5 in for my x, right? If it goes in for the x here, it should go for the x there, so it is 5 plus 3, which would be 8. So, what is m of negative 7?
Negative 4.
Yeah, negative 7 plus 3, that would be negative 4. But I don't always have to put a number in here. What if I said, what's m of L? Yeah, I just put an L in for my x. It's L plus 3. That's it. Now, yeah, if it's not a number, it's not a variable or a letter, but it's both. What if I have m of L plus 5? Well, this all still goes in for my x. L plus 5 plus 3, and that's L plus 8. This right here is where everybody loses it when we do compositions. I don't know why, because they freak out because it's not just the number we put in. Because when I do f of g of x, that's just a fancy way of saying, take g of x, and whatever that function is, put that into f of x. So it's kind of like saying f of g of x that way. if g of x was L plus 5, well, then I just put an L plus 5 into here. I mean, you guys already did that down here. So that's the way we're going to look at it, okay? And that's where people crumble. So we're going to take our same f function and our same g function, and now we're going to do a composition of them. And order does matter. So for this first one, I'm going to take g of x, and I'm going to put that into f of x. All right?
What's that? That's nice.
Sometimes. So f of x is x plus 1, right? So whatever g of x is, that's what I'm putting into f of x. All right? What is g of x? Yeah, so I'm going to put x squared minus 1 into my function x plus 1. You do what now?
You put x squared minus 1 x squared minus 1 plus 1.
Yes, this whole thing has to go in for the x. So it's x squared minus 1, then I have my plus 1. And now, I'm just combining like terms because I'm adding things, right? So what can I do? Yeah, the negative 1 and positive 1 cancel. So that is
just got to remember to like, because there's an x there now.
Yes. That's exact. Because if this was a 5, you would just put a 5 in for that x. It's the same thing. The big deal is a variable is a number. Who cares? All right? Now, what about g of f of x? Now we're flipping it. So now we're taking f of x and putting that into g of x. So, that's like saying g of f of x. And our g of x function is x squared, sorry, that is bad, x squared minus 1. And what's f of x? X plus 1. So we put an x plus 1 into my x here. So let me, yeah, it's x plus 1 goes in for this. I've got to square it now. Minus 1. Does anyone know? Can anyone square that without having to write it down? What do we got? What do you think that's going to expand out to?
You get x squared.
Yeah. Plus 2x.
Plus 2x.
Plus 1. And then you still have your minus 1, right?
So you get x squared plus 2x.
Yeah. So just to reiterate, this comes from foiling this here. If I have x plus 1 times x plus 1, I get x squared plus 1x plus 1x plus 1. So that's where my x squared plus 2x is plus 1 comes from. All right? And now, yeah, I can combine any like terms. The only thing that can combine are my plus and minus 1, and they cancel. So this is really x squared plus 2x. That is g of f of x right there. It's not horrible. It's not horrible at all. What do we get when we do the composition g of f of x? What did you guys get for an answer? Radical x squared minus 1. And that's perfect because I'm going to take f of x and put that into g of x. So it's g, and what's f of x? X squared minus 1. And I'm just going to put that under the radical sign. And that's exactly what you get. You get radical x squared plus 1. All right? But now, ooh, I had the minus up here. Oh, starburst. Starburst. All right. So, the domain. The domain for radicals tells us what? What can or cannot be under the radical? Right. This expression cannot be negative. It can be 0. It can be bigger. It just can't be negative. So we write that this way. X squared minus 1 has to be greater than or equal to 0. Now, if that was just x minus 1, I just add 1 to both sides here. I'm done. Since this is x squared, I know there's two numbers that are going to satisfy this. And on top of that, the two numbers. It's either going to be everything on the number line between those two numbers, or it's going to be everything outside those two numbers. So I'm actually going to have to use a number line. And I think that's the easiest way to do it. And what I'm going to do is this. I'm going to factor this instead of equal to 0 and figure out what numbers are actually the equal to 0 part. So if I have x plus 1 times x minus 1, that's what you told me that factored into when we did the division problem?
Yeah.
That equals 0, and I t-bone, what are my answers? Yeah, this will be x is negative 1, and this will be x is positive 1. So if I put those on a number line, because it's an inequality, right? Negative 1, positive 1. Are these circles filled in or empty?
Empty.
They're filled in because it can include. It can include. Now, here's what I'm going to figure out. Either, because it's an inequality, it's a whole string of numbers. That's just 1 or 2. It's either going to be all the numbers in between 1 and negative 1, including 1 and negative 1, or it's going to be all the numbers, or it's going to be all the numbers outside.
We have it on that. So, yeah.
We've done it. We just haven't done it in so long. But you see how you can't forget things? I know. I'm repeating what you're saying. I'm agreeing with you 110%. So how do I figure it out? Just pick a number and test it. Zeros? Pick 0. If 0 works, then all the numbers in between are your answer. If 0 doesn't work, then the middle section can't be your answers, and it will have to be everything on the outside. So I'm going to plug my 0 right into here. So I'm going to say 0 squared minus 1 is greater than or equal to 0. Is negative 1 greater than or equal to 0? No. Then 0 can't be in the answer, and it's this way. So when I say my domain for this problem is x, all the x's that are equal to or less than negative 1. So x is less than or equal to negative 1, comma, and all my x's that are 1 or bigger. So greater than or equal to 1.
I do.
All right, this next one. What do I get when I have f of g of x? What is that?
You get f under a radical, so you get fx.
X minus 1? Is he right, everybody?
Yep.
Okay, so what's g of x?
G of x is
This is x squared?
It's really x.
And so it's radical x is what g of x is, right?
Yeah.
Oh, we were, and then I'm just going to, and this is x squared minus 1?
Yeah.
That's what f of x is. So we're going to put that radical x in here, and the beautiful part,
Yep.
yep,
This is
just like addition and subtraction are opposites and cancel, multiplication and division are opposites and cancels, squaring and square rooting are opposites and canceling, so I get x minus 1. That's awesome. But what's my domain? And be careful here. What's my domain? Close. Close. If I looked here and looked at my domain right here, can I put any number in for x? I would say all real numbers. But here's where we got to be careful. This is just the simplified version of this, the composition. And what's the composition say? The composition said it's radical x squared minus 1. How come I can't put any real number in there? I can't have a negative under the radical. If this radical is negative, it's an error. If I were to put it in the graphing calculator just like this, with the parentheses and all, I would get an error for negative numbers. If I put it in like this, I get all real numbers. But this is the composition. That's the simplification of it. So my x's, they got to be 0 or bigger, don't they? So you got to be careful. When we do this composition right here, order of operations, whatever x is, I need to evaluate that under the radical first and then square it. So if x is negative, it won't work. So just be careful when I do things like that. They try and trip you off. The composition part, you guys got down. Just, make sure you get the domain when they ask you for domain.
There's a composition